We've all used it, right? That little tube of superglue that seems to work like actual magic, fixing just about anything in a few seconds. Well, it's not magic. And today we're going to pull back the curtain and show you the real science behind one of the strongest glues you've probably got in your house. So, how does it really work? What is happening that lets this clear liquid create this incredibly strong bond almost instantly? Is it heat? Does it have to dry in the air? The answer is honestly way more surprising than you'd think, and it's happening all around us, all the time. And this is the core puzzle, isn't it? Inside that tube, it's a perfectly stable liquid. But the second it touches your fingers, bam, it's a rock-solid bond. So how can it be both a liquid and a solid at pretty much the same time? Let's figure this out. To really understand the so-called magic, we have to start with its secret ingredient. Let's meet the chemical that makes this whole thing possible. The secret ingredient is a molecule called cyanoacrylate, and the key to its incredible power is right there in the definition: moisture. You see, cyanoacrylate is an adhesive that's specifically designed to react and harden only when it touches water. So you can forget everything you thought you knew. You don't need to warm it up. You definitely don't need to blow on it to dry it. In fact, that kind of does the opposite. The one and only thing it needs to kick off its powerful reaction is just the presence of a little bit of water. And here's the kicker. Even surfaces that feel perfectly dry to you and me are on a microscopic level covered in this thin, invisible layer of moisture just from the humidity in the air. Your coffee mug, the desk you're sitting at, and yeah, especially your skin. They all have the one thing superglue is waiting for. Okay, so we know the trigger is water, but what's the crazy chemical reaction that moisture actually unleashes? Let's take a look at how the magic of polymerization really happens. The process is called rapid polymerization. Now, that sounds super complicated, but the idea behind it is actually pretty simple. Just think of the liquid glue as a bunch of tiny, single molecules called monomers. When that trigger, water, gets pulled, these individual monomers instantly start linking together, almost like they're holding hands, to form these incredibly long, strong chains called polymers. So it's basically this four-step dance. 1, the cyanoacrylate monomers touch those invisible water molecules on a surface. 2, this contact triggers an immediate chemical chain reaction. 3, those monomers start linking up into those long polymer chains. And 4, these chains then cross and interlock, forming this super strong, rigid plastic mesh that just locks the two surfaces together. And all of this happens in just a few seconds. It's wild. Now that we know that, we can go back and solve that initial mystery really easily. Why superglue sticks to us, but not to the inside of its own container. And here's the answer. Your skin always has a thin layer of moisture on it. So the moment the glue touches it, the polymerization reaction is switched on. Inside the tube, though, it's kept perfectly dry. With no moisture, there's no trigger. The reaction stays off, and the glue just stays liquid, waiting. Oh, and a quick but really important safety note. While the glue itself isn't toxic, that bond it creates on your skin is incredibly strong. If you try to just pull your fingers apart, you can actually tear your skin. The best way to get it off is with something like acetone, nail polish remover, which helps dissolve that bond nice and safely. So let's take all this science and put it to work. Now that we know how it works, we can get a much better idea of where it works best and maybe where you should never, ever use it. Superglue is fantastic for porous stuff like wood and ceramics, and also most plastics and metals, because they all hold on to that little layer of moisture. But it really struggles with oily or greasy surfaces because they repel water. And trying to use it on something that's already wet or soapy, yeah, that's a non-starter. Too much water can actually get in the way of a clean bond. So why does a superglue bond fail sometimes? Well, there are a few usual suspects. Using a giant glob of glue is actually less effective. A thin layer is always, always better. Dirty or oily surfaces just prevent a good connection. And really smooth surfaces, like glass, don't give the polymer chains enough texture to really grab onto. Oh, and if it's too cold, the chemical reaction can slow way down. The key is to keep it clean, dryish, and use just a thin layer. Now for a little history lesson. You'd probably think a substance this useful must have been the result of years of dedicated research, right? Well, what if I told you it was a complete and total accident? No, it's true. During World War II, scientists were actually trying to create a crystal clear plastic for precision gun sights. But instead, they accidentally came up with this cyanoacrylate formula that had one really annoying problem. It stuck to absolutely everything it touched. They considered it a failure, but later on, its incredible ability to bond with skin was recognized, and it was even used in emergencies to close wounds right there on the battlefield. After all that chemistry and all that history, it's pretty amazing to think that it all comes down to just one single thing: the simple, everyday molecule that turns this liquid into a solid: water. All right, so let's do a quick recap of what we've learned. Superglue's secret ingredient is cyanoacrylate, and it gets activated by water. It bonds using a process called rapid polymerization, which creates a strong plastic mesh. It sticks to your skin because your skin has moisture, and it stays liquid in the tube because the tube is kept perfectly dry. Simple as that. So the next time you fix something in seconds, remember this: it is not magic holding it all together. It's chemistry, harnessed in a tiny tube that uses the invisible water that's all around us to create an almost unbreakable bond. Your world is never completely dry, and that is exactly what superglue is counting on.